Okay, so the last section we're going to do with integration set number 3 is solids of revolution. Remember that if you're finding solid revolution when you're doing area, your first step is to draw the graph. Second step, find your intersection points, and then identify your top curve minus bottom curve, that sort of thing. So area between curves is top curve minus bottom curve under the integral. And if you have a sideways parabola, that sort of thing, it's going to be x equals, and you're going to have y limits. It'll be right curve minus left curve. So I've put the formulas there for you. Your cross sections formulas that we've been using. So let's just jump right into it. I did this recently, so it shouldn't be too bad. Okay, so part A, it says let f of x equal to 2x squared minus 6x plus 4, and g of x equal to the cosine curve. Okay, so the hard part about this question is identifying which one's which. Okay, so this is f of x because it's a parabola and it's going to cross. If you're going to do your intersection point, your zeros, it would cross here and here. Cosine is going to start at a peak up here, and it's going to go down like that. So that's going to be your g of x. Okay, part A, it says find the area. So your intersection points, your limits for this case are going to be 0 and 2 because it gives it to you. Okay, so area is the integral from 0 to 2 of your top curve minus bottom curve. So 4 cosine of 1/4 pi x minus 2x squared minus 6x plus 4 dx. Okay, so when we go to do this, your u is going to be 1/4 pi x. Your du is going to be 1/4 pi dx. Now I don't have the 1/4, so I got to get rid of it. So it becomes 4 over pi is equal to dx. Okay, so when we integrate this, the integral of cosine is sine, and then we're going to multiply 4 over pi times 4 is 16 over pi sine of 1/4 pi x, and we're going to evaluate it from 0 to 2. Okay, so sine of pi over 2 is 1, so this becomes 16 pi. Sine of 0 is 0. Okay, so we did that portion. Let's go do this portion. So we get 2/3 x cubed minus 3x squared. Add 1 to the exponent, divide by the new exponent, plus 4x, and we're going to go from 0 to 2. 2 cubes 8. 8 times 2 is 16/3. 2 squared is 4. 4 times 3 is 12. Plus 8. And then we're going to plug in a 0. Excuse me. So when we plug in a 0, we get 0. Combining our like terms, we get 16/3 minus 4 around the world gives you 4/3. Okay? So the total area between these two curves is going to be 16 over pi minus 4/3. Okay, the minus comes from this right here. Okay, part B and part C, they're just setups. Okay, so we want to evaluate it we're going to revolve it around the line y is equal to 4. Is up there. So what we're going to do is we're going to draw our ladder. We're going to end up having white space. So we'll have to do an R big and an R little. So your R big is your top curve minus bottom curve, and it extends the whole length of the ladder. So it's going to be 4 minus f of x, which is 2x squared minus 6x plus 4. And then R little is going to be top curve minus bottom curve, and you have to subtract out this portion right here. So it's going to be 4 minus your g of x, which is 4 cosine of 1/4 pi x. Now we're going to set up our volume. So volume is equal to pi times the integral from 0 to 2 of 4 minus 2x squared minus 6x plus 4 squared minus our little squared. Now, if you want to use F's and G's in this section right here, perfectly fine with that. Okay. Last part says the region is the base of the solid for it's perpendicular to the x-axis and it's a square. So volume of a square, when we do this, is the integral of side squared. And your side is going to be your top curve minus bottom curve. So it's 4 cosine of 1/4 pi x minus 2x squared minus 6x plus 4 squared dx, and we're going from 0 to 2. Okay? So this should be fresh in your mind because we just did this like 2 weeks ago. Okay, next one. So this is going to be calculator. So part A says you have this graph, x to the 4th minus 2.3 x cubed plus 4, and the line y is equal to 4. First part says you want to revolve it around the line y is equal to a negative 2. So I'm going to draw my line y is equal to a negative 2, and I'm going to do my ladder like that. Now we have to find these intersection points right here. So this is 0. Don't assume it's 0. It's just, it comes out to be 0 whenever you do the calculator. And let's find the other intersection point. So x to the 4th minus 2.3 x to the 3rd plus 4, and I'm going to graph it. My window, zoom 6. Okay, and then y is equal to 4. You put that in there also. Okay, so we need to find that intersection point right there. So we do second calc, 5, intersect. Go close to it. And you get 2.3. Okay, so for part A, it says find the volume of the solid when we rotate it about that. So we're going to have an R big and an R little because we have white space going on right here between the region and the line, the axis of rotation. So volume is going to be pi times integral from 0 to 2.3 of R big. So when we do R big is going to be top curve minus bottom curve. So this line y is equal to 4. So it's going to be 4 minus a negative 2. And R little is going to be top curve minus bottom curve to subtract out the white space. So top curve minus bottom curve, you're going to subtract that out. Comes out to be wait, I'm looking at what it is. Top curve minus bottom curve. Yeah, it should be this graph minus a negative 2. I messed that up whenever I did that earlier. Okay, so whenever we're doing solids revolution and it's a washers, we go the whole length of the ladder, and then we do top curve minus bottom curve to subtract out this portion right here. Okay, so we're going to put that in y equals and we're going to integrate our calculator. So we're going to put that in y1. So 4 minus a negative 2 is 6. And then we'll do x to the 4th minus 2.3 x cubed plus 6. Okay. And then we're going to do math 9 bars y1 squared minus y2 squared, comma x, comma 0, comma 2.3. And we're going to multiply it by pi. So 98.8678 is my answer. Let me change this really quick. So x to the 4th minus 2.3x cubed plus 4 negative 2. Okay, cool. Now, part B. It says the region is the base of the solid. For the solid, each cross-section perpendicular to the x-axis is an isosceles right triangle, with the leg is r. Okay? So, area of a triangle is 1/2 the base times the height. And the bases are going to be the region R, so it's your top curve minus bottom curve. So it's 4 minus x to the 4th minus 2.3x cubed plus 4 quantity squared dx. It says find the volume. Okay, so we're going to put that into y equals. So I'm going to do 4 minus x to the 4th. So 4 minus x to the 4th minus 2.3 x to the 3rd plus 4. And I'm going to quit. I'm going to do math 9 vars. I'm squaring it, comma x, comma 0, comma 2.3 times 0.5. And I get 3.5737. Okay. In the last one, it says the vertical line x is equal to k divides the region into two equal areas, right? But do not solve an equation that involves k. Okay. So we know that the area from 0 to k of top curve minus bottom curve has to equal the integral from k to 2.3 of top curve minus bottom curve. And that's all it's asking for. Okay, so we're taking some line k and we're dividing it into two equal areas. So we're going to do top curve minus bottom curve to find your area. Okay, let me write this down. These answers 3.5737. And I got 98.8678. Okay, next example. Okay, it says let f and g be those functions in the two regions. So part A, we want to find the area of R and S and we want to add them together. Okay, so 1 plus x plus e to the x squared minus 2x, we put that in the calculator, and then x to the 4th minus 6.5x squared plus 6x plus 2. Okay, so the bottom curve looks like it's the E one. Okay, so f of x is on bottom and g of x is on top. Okay, and then f of x would be on top here and g of x would be on bottom. So we need to make sure we find our intersection points also. So if you want to change your window from like 0 to 2 and 0 to 4 for y max, because it says it's going to 4. So you can get a little bit better idea of what the graph looks like. Okay, so we're going to find our intersection points. So second calc intersect is 5. Boom, boom, boom. I got 1.0328. Okay, and then 2. So, when we go to do this and set this up, we're going to do the integral from 0 to 1.0328 of g of x minus f of x. I'm just going to write g of x minus f of x to save time. And then I'm going to go from 1.0328 to 2, and it's going to switch f of x minus g of x dx. Now, what you're going to do is you're going to math 9 this, and we're going to do 2 separate integrals, math 9 vars, y1, it should be y2 minus y1, comma x, comma 0, comma 1.0328. You get 0.9974. Okay, and then we're going to do the same thing, math 9 vars, and then we're going to do y1 minus y2, comma x, comma 1.0328, comma 2, and we get 1.0069. And we're going to add them together. Okay, you should get 2.0043 for the final answer. Okay, part B. It says that let S be the basis of solid for cross sections perpendicular to the x-axis are squares. So volume integral of so we're going to do squares, squared side squared. And S goes from 1.0328 to 2. Okay? And your top curve minus bottom curve is going to be f of x minus g of x. So your y1 is f of x. Okay, so we're going to do math 9. And we're going to do y1 minus y2 squared, comma x, comma 1.0328, comma 2. And I got 1.2832. Okay, last portion. We'll be done with this. It says, let h be the vertical distance between the graphs of f and g. Find the rate at which h changes with respect to x at x is equal to 1.8. So vertical distance is going to be how much is this distance in the y direction changing. Okay, so we're going to do h of x is equal to f of x minus g of x. Now we want to know the rate at which that's changing, so we're going to take the derivative at 1.8. Okay, and we can use our calculator. It's going to work out really easy. So we do math 8 is your derivative. I'm going to do y1 minus y2, because that's f of x and g of x, comma x, comma 1.8. So I get negative 3.817. Okay, so it'll be decreasing because it's a negative derivative. Okay, hopefully this was a good review of solids of revolution with free response. We'll continue to do these over the next couple weeks. So you should be good at this. If you have any questions, let me know. Have a good one.